Welcome to the distance learning program on Android by Innabus. Graphics and Animations. In this chapter, we will be covering the following topics: graphics in Android, creating animations, and an introduction to OpenGL ES for animation in Android. Graphics in Android. Under graphics in Android, we will see the following topics: drawing with XML and exploring XML drawable shapes. Drawing with XML. In Android, simple drawings can be created using an XML file approach. Using XML has many advantages. The main reason is that it is easy to implement, and the graphics described by XML can always be programmatically changed later. To create a drawing with XML, one or more drawable objects are created which are defined as XML files in the drawable directory. Another advantage is that the design can always be externalized from the business logic. Now we will see a demo of drawing with XML in Android. First, we'll create a new Android project. We'll name the project as Drawing XML Demo. And select the build target and name the package. Now we'll open the project and create a new Android XML file. The resource type of the file is drawable, and the name of the file is shape.xml. We'll select the root element as shape and press finish. Now we will add a solid tag inside the XML file. Now we'll set the color of the solid to be blue. And save the XML file. Now we'll open the layout of the default activity and add an image view below the text view which is already present inside the layout, and select the shape as the drawable for the image view and press OK. We'll make the image view to fit the width of the screen and save the file. Now we'll run our application. The drawing XML demo activity has been launched, and we can see that the image view is filled with the shape drawable. Exploring XML drawable shapes. Android provides the ability for developers to programmatically draw anything that is required. Multiple XML files representing different shapes can be created to draw multiple shapes with XML, thereby resulting in composite drawings. Now we will see a demo of exploring XML drawable shapes in Android. For this demo, we will reuse the same project which we used for the drawing XML demo. We will open the project and create a new drawable file. Select Android XML file and the resource type as drawable and the file name as shape_1.xml and the root tag as shape and press finish. By default, the shape tag in drawable file results in a rectangle. We can edit this by using the type tag, and we will set it to oval, and inside the shape tag we'll have a solid tag, and we'll set the color as black, with zero transparency. We'll also add padding values to the shape. Now we will add a stroke tag. This adds a border to the shape. We will set the thickness of the border as 1 sp and the color as white, and save the XML file. We'll create another shape XML file. We will name it as shape_2.xml and select the root as shape and press finish. We'll add the solid tag and set the color as red. We will also add a stroke tag. The color of the stroke as white. We will set the thickness of stroke as 4 sp and mention it as a dash by using the dash width tag. We'll also add another property called dash gap to specify the distance between two dashes. We'll add corners to the shape by using the corners tag. We'll set the radius of the corners as 4 dp and add some padding values. And we'll save the XML file. Now we will add the third shape file. Select the resource type as drawable and name it as shape3 and select the root element as shape and press finish. Again we will set the type as oval. This time we will create gradient colors instead of solid colors. Gradient colors are set by using the start color and end color tag along with the angle of radians, we'll add some padding values. We'll also add corner radius. And save the XML file. Now we'll create the last shapefile. We'll name it as shape_4 and select the root tag as shape. Now we will create a shape of type line. And we'll add a solid tag. We'll set the color as green. We'll also add a stroke for the shape. Let the thickness of the stroke be 1 sp and the color be white. We will add the padding values. And finally we will add the size of the shape. And save the XML file. Now we'll go to the layout file. We'll remove the image views that we added and the text view which was already present in the layout, and edit the layout file. We will add an image view. We will add the source as the shape1 file. Similarly, we'll create 3 other image views and change their source to shape2, shape3 and shape4 respectively, and save the XML file. Now we'll run our application to check whether the drawings are correct. The activity is launched and the 4 shapes are drawn with their respective values. The first, second and fourth shape have solid values, while the third shape has a gradient value. The second shape has a stroke with a dashed border. Creating animations. Under this heading, we will see the following: Android's frame-by-frame animation and programmatically creating an animation. Android's frame-by-frame animation. Simple animations can be created by showing a set of images one after another to give the illusion of movement. Each frame image is set as a drawable resource. Then the images are shown one after the other in the background of a view. A set of resources is defined in an XML file, and then the animation drawable start method is called. Now we will see a demo of Android's frame-by-frame animation. First, we will create a new Android project and name it as animation demo, and select the build target and name the package. We'll open the project and add a new Android XML file. Select the resource type as drawable and name it as simple animation.xml. We'll select the root element as animation list and press finish. The new XML file is created in the drawable folder. We will create a new folder named anim, and we'll move the drawable to the anim folder. Now we will add the required images inside the animation list. I have a set of 6 images which I have put in the drawable folder. These 6 images are frames of a bouncing ball. Now inside the animation list tag, we add an item tag. And set the drawable and the duration as 50 nanoseconds. I copy the item tag and paste it another 5 times and change the drawable to next frame image every time. And also I set another property in the animation list tag called one shot, which I set it to false, which indicates that this is a repeating animation. Now going to the main layout file, we remove the text which was already present in the layout and add an image view. And set the source as simple animation. We'll set the gravity of the linear layer to be center and save the XML file. We'll remove the source tag from the image view as of now. Going to the default activity, we will create an image view object and map it to the image view we have created in the XML file. We will set the background of the image view with the animation file we created. We will create a new class called animation task, which extends the timer task. And inside the run method, we'll copy the image view object and paste it there. We'll create a new animation drawable object. And map it with the background we assigned for the image view. We need to make sure that we typecast the return object to animation drawable. And we'll call the start method on the animation object. Back in the onCreate method, we'll create a new object for the animation task. We'll also create a new timer object. And we'll use the schedule function to call the animation task. Now we'll run our application. The animation demo activity is launched and we can see the animation running. Programmatically creating an animation. Animations can also be created programmatically by the use of the following: threads, handlers, and message. All these three interact with each other to form animations programmatically. Introduction to OpenGL ES for animation in Android. The Android platform supports OpenGL for embedded systems. It is the embedded systems version of the OpenGL standard, which defines a cross-platform and cross-language API for computer graphics. The OpenGL ES API does not support the full OpenGL API as it has to run on a variety of mobile phones, PDAs, video game consoles, and other embedded systems. In short, OpenGL ES API is a cut-down version of OpenGL API. Graphically intensive applications such as games, graphical simulations, visualizations, and all sorts of animations can use OpenGL ES to render 2D and 3D graphics. An application running on a computer using OpenGL 1.3 can be run on Android after light modification, provided it is supported by the hardware configuration of the device. So, OpenGL ES provides a wide range of opportunities for developers who are interested in gaming and other animation-based visualizations.